Welcome all. So today's video lecture, that is signal and systems. The topic is classification of signal and system. It has a contents like introduction to signal system, types of signal system, elementary continuous time signal system, represent of discrete time signal system, elementary discrete time signal system, basic operation of signal, classification of signal, classification of system. Classification system already said a video by me. So we are going with the introduction to signal and system. What is a signal? A signal is defined as any physical quantity that depend upon time, space or any other independent variable or variables. So mathematically we describe a signal as a function of one or more independent variables. So for example, we can say S1 of t. Okay, this is a signal S1 of t. So S1 of t is equal to what? If I write a term, S1 of t is equal to 5t, where t is the time. So here S1 of t, the signal depend upon time. Similarly, you can see if I write an example S2 of t. S2 of t is equal to what? 20 t square plus 60. So it also depend upon time. So what I said, the physical quantity that varies with time or depends with time, space or any other independent. So time it says, so it is a equation. Similarly, I can give another example, S of xy. So it depend upon xy, x and y are the independent variables. Okay, I said independent variable or variable. So I am putting two variables. So I will write 3x plus 2xy plus 20y square plus 7. So it depends upon, you can see, independent variables x and y. Okay. So this is the example of signal. So what is the signal? It depends upon, it is the physical quantity, varies with time, space or any other independent variable or variable. So it is the example we have given. Similarly, what is the system? A system is defined as physical device or software realization that performs an operation on signal. For example, filtering. What is filtering means? Removal of noise from the signal. So noise is the unwanted signal which is added to the desired signal. So next topic we are going to types of signal. Generally, there are three types of signals in broadly classified. First one is continuous time signal, second one is discrete time signal, third one is digital signal. Continuous time signal is also called analog signal. So in the signal system course, generally we are using continuous time signal and discrete time signals, not the digital time signal. So in this my video lectures, I will not go to digital signal, only basic introduction I will give. Operations, everything will go on continuous time and discrete time signals. So what is continuous time signal? Always remember continuous time signal, where it is depend upon the continuous time. So it is bracket, you can see it is t. If bracket it is t, that is called continuous time signal. If bracket it is n, that is called discrete time signal. So continuous time signal defined for all values of time t. All values of time t and represented by x of t. So x of t means continuous time signal. X of n, you can say, that is discrete time signal. A continuous time signal is also called an analog signal. Example, ECG, electrocardiogram signal. Electrocardiogram signal is what? Which detects the heart rate. Okay, it is the representation of the heart. It is that heart, it detects the heart rate, all the components. It consists of 5 components: P, Q, R, S, T. Similarly, we can say AC power supply. This is also a continuous time signal. Then we are going to discrete time signal. What is discrete time signal? It is defined instant of time and represented by x of n, where n is the index. See, continuous time signal we are represented by x of t, where t is the index, that is the continuous time, whereas discrete n is that, here you can say interval of time. Okay, some signal may be discrete depending on continuous time signal, that amplitude of each interval. You can see here in the diagram, minus 3 it is 0, minus 2 0, minus 1. So you can see this is the discrete interval. Okay, and you can see x-axis consists of only integers, positive or negative sides. Okay, so this is the discrete time signal. So discrete means it is that x-axis we can put 0, this is the origin, we can say 4 with the value. First it is minus 1, you can say any value. 2, it is, you can 2. Okay, similarly this is the n, minus 1, minus 2, you can write the value. So what is the discrete time signal? It is representing the discrete sequence, and the representation of discrete time signal I will go in the next video lecture. So digital signal is what? A signal that is discretized in time and quantized in amplitude. So it is in the quantization technique we are using. It will read in the analog communication things. The signal consists of binary values, zeros and ones, that is digital signals. So basic thing is, what is that unit step function? It is denoted by u of t. So u of t is equal to 1 for t more than 0. So it is a continuous time signal. So I am putting continuous t. Okay, x axis t. Y of x is, I am writing it as u of t. So what I said, if it is more than 0, this is 0. More than 0 is 1. So this is 1. Okay. So u of t equal to 1 for t more than 0, 0 t. So this is the unit step function. Similarly, second one is, we go unit ramp function. Unit ramp function denoted by r of t. So r of t is equal to t for t more than 0. T more than 0 means, let this is t. This is the y axis. Let I am writing it r of t. Okay. So t more than 0 t. T less than 0 means this is minus 1, all values less than 0, it is 0. So it is a straight line for less than 0. More than 0. When 0, it is 0. When t is equal to 1, we will get 1. When t is equal to 2, we will get 2. When t is equal to 2, we will get 2. So I will plot this line. So this is called r of t, unit ramp function. So what is r of t? T is equal to t for t more than 0 and 0 for t less than 0. So this ramp function can be applying unit step function obtained by applying unit step function to an integrator. So r of t is, you can see, u of t is equal to what? U of t is 1 for t more than or equal to 0, 0 otherwise. So integration of 1 dt is t. Okay, that's why you say r of t is integration of u of t dt. Similarly, u of t unit step function obtained by making it dr of t by dt, derivative. Okay, to apply differential. Parabolic, you can see u of t is 1 for t more than equal 0, 0 otherwise. Similarly, p of t is equal to t square by 2. So for t more than 0 and 0 for, so you can see p of t is equal to t square by 2 u of t. So we are multiplying t square by 2 u of t. So what you can say, parabolic function, this is t, this is 0, okay, this is 0. So for example, I am taking 1. So 1 means half, 0.5. Okay. Similarly, if I am taking 2, 2 to 4, 4 by 2, 2. Okay. So like that we will get the function, correct? So this is unit parabolic function. Next one is unit impulse function. Unit impulse function is del of t equal to 1 for t is equal to 0 and 0 otherwise. So when t is equal to 0 only, you will get a function. Other than that, we will get not any value. So that is called unit impulse function. Now properties. First property is integration from minus infinite to infinite x of t del of t dt is equal to x of 0. Okay. What is del of t? I said already that unit impulse function del of t is equal to 1 for t is equal to 0 and 0 otherwise. So we can see here, in the integration of x of t, for all the values of x except 0, we will get 0 because 0 otherwise. So only we will get the integration when t is equal to 0. If t is equal to 0, because del of t, del of, we know that del of 0 is 1, del of 1 is 0, del of minus 1 is 0. So what it says, del of t equal to 1 for t equal to 0, 0 otherwise. So x of t I multiplied. So if I multiply anything with del of t, for example x of 1 integration, I am going with del of 1. So I will get it as a 0 because del of 1 is 0. Similarly, if I go like that, so only it exists for 0. So I will get here x of 0 into del of 0. Del of 0 is 1. So it is x of 0. Hence, it is proved. So I hope you got it. The del of t, when t is equal to 0 only I will get 1. So del of 1 is other than t, other than the value of 0, it will be 0. So in the bracket what is there, that is 0 means del function will be 1 or impulse function. Second property is x of t, del of t minus t0 is x of t0 into del of t minus t0. So the thing is that t minus t0 is equal to 0, then only del of t minus t0 is 1. So that implies t equal to t0. So if t is equal to 0, so in place of x of t, I can write x of t0. So it will be x of t0 multiplied by del of t minus t0. So it is therefore x of t0 is equal to x of t into del of t minus t0. Why? When this is 0, then only I say del of t is equal to, or del of 0 is equal to 1. Other than that, we will get 0. So it will get the same value when t minus t0 is 0, t equal to t0. So I proved in place of t, t0. So this is another proof. X of t minus t0 is equal to x of t0 into del of t minus t0. So next one is integration of in minus infinite to infinite x of t del of t minus t0. Last just only I said x of t minus 0 t into del of t minus t0 is x of t0 del of t minus t0, as you said last proof just, is equal to x of t into del of t minus t0. So in place of x of t del of t minus t0, I will put minus infinite to infinite x of t0 del of t minus t0 dt. Okay. So here we know for t minus t equal to t0 or t minus t0 is equal to 0, or del of t is equal to del of t minus t0 is equal to 0, del of t minus t0 0 means we will get 1. So in that case we will get x of t0. So it will be x of t0. So it is proved. Okay. Similarly, another property is del of at is equal to 1 by mod a del of t. Next one is rectangular function. Rectangular function denoted by pi of t. It is equal to 1 for mod of t less than equal to half, 0 otherwise. So minus half to half it is 1. Other than that it is 0. You can see minus half to mod t is minus half to half, it is 1. Other than that 0. Next is rectangular function, sorry, triangular function. Triangular pulse function is what? You can see here. Okay, we know that one equation is that, let it is x-axis. Okay, this is x-axis value is minus a, y 0. This is 0, 1. Okay, we know the formula that y minus y1 by y2 minus y1 is equal to x minus x1 by x2 minus x1. So my value if I put here, first this is x1, y1, x2, y2. Okay, x2 is 0, y2 is 1 here, x1 is minus a, y1 is 0. So here I will put y. So here our y is del a of t. Okay, so here I will put y. Y means del a of t. Y is equal to, you can see, del a of t. Del a of t. And what is x here? X is equal to t. You can see this is the time axis. So x is equal to t. Okay. So if I put, okay, if I put x of t, okay, so y minus y1. So del of t minus y1. What is the y1? 0 divided by y2 minus y1. Y2 is what? 1 minus y0. So I will get del a of t is equal to, okay, minus. Next, we are going x. X is t. Okay. X minus x1. X1 is how much? X1 is minus a. Okay. Divided by x2 minus x1. x2 minus x1 means 0 minus a. Okay. So if I take minus common to make the denominator positive, okay, so it will be a minus t by a. So a, if I divide it, that is equal to, you can say, a by a is 1 minus t by a. This is for this side. Similarly, we will make, so this will make modulus. So it will be del a of t. You can see here. So what I got? Del a of t is equal to 1 minus t by a. If I make that negative positive side also, this will be del a of t is equal to 1 minus mod t by a. I hope you got this derivation, how we are getting this equation. Next, we are going sinusoidal function. Sinusoidal means sine wave. So you know x of t is equal to a sine omega t plus phi. So this is t. So we are getting, this is the sine wave. Okay. So amplitude should be same. So this is the amplitude a. Okay. So this is a sine. This is the time. Omega is the frequency. Theta is the phase difference. So phase difference also you can put it. T is equal to time. So now exponential signal. So x of t is equal to a e to the at. If a is equal to 0, x of t is equal to a. If a more than 1, x of t is exponential growing signal. You can see, okay, a is equal to 0 means a t, so is equal to a, because e to the 0 is 1. If a more than 1, exponential growing signal, a less than 1, exponential decaying signal. Similarly, for complex also, the sigma we can put s is equal to sigma plus j ohm. So x of t जो e to the st, e to the sigma plus j ohm into t, sigma t, j ohm t. As e to the j ohm t is, we know that e to the j theta is cos theta plus j sin theta. So j ohm t you are writing cos ohm t plus j sin ohm t. So if s is equal to 0, we will get a straight line. If sigma is more than 0 and ohm is equal to 0, we are going decays exponentially. If sigma more than 0 and ohm is 0, we got increases exponentially. If sigma equal to 0, we get a sinusoidal wave, because a sin that omega t term will become. If sigma more than 0, we are growing sinusoidal. If sigma less than 0, decaying sinusoidal. Okay. So sync function is sin pi t by pi. So you can see this is decaying type signal. Okay, sine wave. So calculate the value, some problems with respect to unit impulse function I will do. So as I said, del in function what is available, if that is 0, we will get 1, other than that it is 0. So here t equal to 10 only, I will get the value. So del of t minus 10 is equal to 1. Other than that, del of t minus 10 is equal to 1 when t minus 10 is equal to 0. So t is equal to 10. Okay. So if I put t is equal to 10, so here you will get either minus a into 10 square. E to the a minus a into 10 square is e to the minus a 100. So answer is e to the minus a 100. So I hope you all got it, this one. Similarly, we will go next question. T square del of t minus 3. So here also same, del of t minus 3, when it is 0, we will get 1. So t minus 3 is equal to 0. As t minus 3 is 0, t is equal to how much? 3. So t equal to 3 means integration only exists for t equal to 3. So 3 square, t square means 3 square or equal to 3 square is equal to 9. So this is the answer. Next is, we can go del of t sin pi t by 2. So here only it exists, this exists from 0 to 5. So limit you check, it is 0 to 5. So here it will become, so it will come for when t is equal to 0. So integration, this the limit exists 0 to 5. So t equal to 0 means sin pi into t means 0 by 2. Sin 0, 0 is, so sin pi t by 2. Okay. So it is sin pi into 0 by 2. So sin 0 is 0. Okay. Similarly, e to the minus t del of t plus 3. So here integration of minus infinite to infinite. So del of t minus 3 means t plus 3 is equal to 0 only, I will get 1. So for del of t plus 3, so implies t equal to minus 3. So in place of t, if I put minus 3, e to the minus of minus 3, we will get e to the 3. Okay. If, for example, in this question only, small difference if we make, integration of 0 to infinite e to the minus t del of t plus 3 dt. Okay. So here you can see when I am making, it will exist del of t plus 3 is equal to 1 when t equal to minus 3, and it is, you can check, this is 0 to infinite, but t is equal to minus 3, it is not in the limit, so this equation will be 0. So hope if you check better getting it whether t value is in the limit or not. If it is not in limit, you will get 0 value. So similarly, another question, you can see del of minus infinite to infinite t minus 5 squared. So here t is equal to 3, you will get a value. So in place of t, you will put 3 t minus 5 whole square. So we will get 2 square is equal to 4. Next one is integration of minus infinite to infinite. So it is two parts. One is here, second one is here. So I can make a two integration, minus infinite to infinite del of t cos t dt. Second one is minus infinite to infinite del of t minus 1 sin t. Okay, dt. So here dt term is that. Okay. So similarly, if I put here when t is equal to 0 only, I will get a value. So del of t is equal to 1. So here if I put cos 0 plus del of t minus 1. Okay. So del of t minus 1 means t is equal to 1 only, I will get this value 1. So t is equal to 1. So sin, I will get sin t or sin 1. So what you got? Cos 0 plus sin 1. Cos 0 is 1. So 1 plus sin 1. Now last problem, okay, that is integration of minus infinite to infinite del of t, minus infinite to infinite del of t e to the minus j ohm t dt. Okay. So what we will do in that? So first thing is I will put here t is equal to 0, as I say t is equal to 0 only, del of 0 is 1. So for t is equal to 0 only, I will get a value. So integration of minus infinite to infinite del of t e to the minus j ohm t will only give the value when t is equal to 0. So I will get del of 1. So in place of t, I will put 0. So it is e to the power minus j ohm 0. So e to the minus j ohm 0 is e to the 0. So it was 0 is 1. This is the answer. I hope you got all the concept of solving problems related to unit impulse function. So next class I will try explain that elementary what is the representation of discrete time signal and some elementary function of discrete time signal. So linking it continuous time discrete time, you can easily understand. So thank you for attending this video lecture. Thank you.